So I'm going to start by welcoming you all. Good morning, good afternoon, good evening. Probably you're surprised that we are having such welcoming, and why I'm saying good morning, it's because, well, at my place it's just perfectly noon, but probably we are having people with different, we have participants from Australia, Middle East, Mexico, Brazil, Lativa. So we try to be as inclusive as possible. So on behalf of CPEX Global, I'm Anastasia, and I would like to welcome you all to ISO 12647, heading for printing process, conformance, and standardization. You might all know that in Germany, there are 250 printers that are ISO certified. So this is important to be ISO 12647 if you are associated with the printing business, either flexographic, offset, or rotogravure. So in this session, we have an amazing trainer, Dr. Abhay Sharma. Hello, welcome.
Good morning.
Who has an amazing professional experience in color management and that particular ISO implementation. In this session, he will provide you insightful learning for various parts of that, requirements, implementation criteria, etc. Give back voice to Dr. Abhay Sharma, that is going to do the great presentation for us today. I will remind you about the break in 1 hour or so, so everyone can feel comfortable and have their needs met. Thank you very much. The mic is yours, Doctor.
Thank you. Good morning, good afternoon, good evening. Thank you, Anastasia. Great introduction. So welcome. We have, this is our title for today is graphic technology, and we're heading for process conformance and standardization. We're going to be talking about color, about numbers, measuring, and here you see a number ISO 126 for this basic CMYK. So we're doing CMYK in the main. Most of these standards I think will change to CMYK OGB, but at the moment they're CMYK. So we just make sure that we're talking about CMYK, RGB, obviously the original image, but it's converted to CMYK. We're doing CMYK printing, and whether it is light cyan or cyan and light magenta or light black and light black, as we have in inkjet proofing, it doesn't matter. It's basically CMYK printing that we're talking about. The other thing that is really important is the color, and there are 3 attributes to color as shown here. The first is hue, and down the bottom here we have different hue, and we'll come back to this tomorrow. There's hue, and that's one of the fundamental parameters of color, and then there's saturation or chromatic color here on the left. And so a color can have a lot of that color and then get less and less, and you can think about diluting ink until it becomes totally clear. So that's another concept, saturation, whether we talk about it in terms of ink or color in a print. And then finally, we have an idea of lightness, and lightness is from light to dark. So 3 basic attributes, and that forms the most of the sensible color systems that we use today, certainly the LAB color system. So hue, saturation, and lightness, 3 attributes for color. We also have screens, and everything that we do is screened. So all of the printing processes we're talking about are screened, whether it's stochastic screening or traditional halftone screening, and then also even whether it's inkjet, that also has a screening pattern. So we will talk about the screen and the screen angles. We know that if there's overlap and interference, we'll get moire, but everything is via a screen. And I've got a microscope to show you a real screen in a few moments. We also talk about measuring color difference in terms of delta E, and that is really a large part of most of the standards that we're going to look at. We know these screen angles that yellow, which is not very visible to the eye, we put at 90 degrees because that's where we would see the effect, and we try to minimize it. And yellow is a very light color. Is anybody doing film still on the call? Are any doing film separations, or are we all direct to plate, CTB, or direct with a CDI, ESCO Spark CDI? Is anybody still making intermediate film? But if not, you can see where these standards and how long they've been around, because they're talking about this control patch that was put in the screen, in the image, and added to the film. So a lot of this work, of course, has started from film, where we did film separations. And so that is in these standards. You can see they have been continuously updated, but some of the original material is still there. We're going to look at a lot of these numbers and LAB. And so we're going to remind ourselves of what is LAB. We're going to try to work with LAB. But basically, if you look at the lightness, 70, 80 is a very light color. Paper, maybe 95. Here's the white, which is paper. It will be 95, 97, maybe 93. And then this is A and B is the color. So anything that's white here is a very high L star, and very little A star and B star. So very low numbers here. It's neutral near the core, and that's how we would use this system. And so we won't talk about CMYK values per se, but what we'd like to do is talk about the color here. And in the top right of our, is my camera on, Anastasia? Can't see my own camera. Anastasia, is my camera on? If it is, then in the top right is is this,
yes, your
is
camera
the Teshka?
is on. I'm
yes?
sorry, I couldn't unlock my mute.
Okay,
I don't want to make any noises in the background for you. So sometimes I need a little bit more time to get in.
To answer. All right, I'll do that. My own camera has disappeared, but in the top right of our slides is a Teshcon, and this is a Teshcon, and we'll use that today to do some measurements. But the whole of the ISO standards is via measurement based. On the right here are two very important settings that are actually on this instrument panel. And on the right of your screen, you'll see two numbers, D50 and 2 degrees. And so setting that on the instrument changes the readings, and we need to be aware of that. And so when you're measuring for your customer, they will specify, you specify which of those settings. And the two settings are the color temperature, the color of the light that we'd like to use as a reference, and also this 2 degree observer. For all of the material we're looking at, because it's at this distance here, this is a 2 degree observer. If it was a far wall, then it'd be 6 degrees, but basically they should be 2 degrees. And I've worked and visited customers, and we don't really know what these settings are. And so we don't pay attention that they're set, and they do change the value. And this could be the difference between a pass and a fail. So please know what these are and make sure they're set in the level that you want them to, the numbers that you want them to be set at. And D50, 2 degrees, is normally what we would like them to be at, unless there's a reason to have them at another value. All of our press sheets should and must have a control bar for Flexo. The FTA has some very nice samples that you can get. Nearly every company, every prepress company has these. Unless there's something in this to in our press sheet to measure, really we don't know, we're just eyeballing it. So without something in it, I know it takes up some real estate, but it can be trimmed unless we have something to measure and monitor, really we're flying blind. And this whole process that we're talking about today and tomorrow is based on measurement. And so to measure something sensible, you have to have valid tests in the press form. So if we're going to try and measure moire, screen resolution, vertical and horizontal, the color at the solid, the half tone, the 3/4 tone, and the 25%. So we need to put, if those are what we want to evaluate, they have to be in there. And so there are a number of these standard forms available. Everybody should start to develop and make sure they have something on each sheet. This is a printing process is a continuously moving process. And so it can drift. And so every sheet must have something. I agree, it takes up space, but it can be removed. And unless we are continuously monitoring, it's really not helpful for us to try and measure anything. And many of the printing systems have a camera that will flash and inline continuously measure. So we have to put them in there for this system to work. And once we do that, we can track, we can see how things drift, we can see whether the first shift is more efficient, and we're always having problems at the second shift or the third shift. People are coming after dinner and they're a bit more relaxed at night. And so we really can give this, or press A is really unstable and really drifts, while press 2 continuously hits the bars. So once we get this information, it is so important. And we can use this really to help us improve our processes. So let's put in the data into the control strip that we want to then evaluate and track. One of the things that we need to do is measure, and this is the 0 to 45 measurement geometry. And so you'll often see this 0 to 45, and you can see here light comes down at 0 degrees, and then at 45, it's reflected and picked up by an instrument. So just another setting. People, unless when we get to metallics, we'll talk about different, but for normal optical light measurement, 0 to 45 geometry is 0 for the light, 45 for picking up, or 45 for the light and 0 for picking up, it doesn't matter. But for metallics, things get a bit different, but 0.45 is the normal geometry for these measuring instruments. Solid ink density. So we're moving away from density measurements, but it's still used, and it's very helpful for process control. Something I'd like you to see here is this, that if this black ink is the same black ink, notice that on a coated paper, we can get to a 1.8 to a 2 density. The same ink on an uncoated paper, really we can't get that high, 1.5 to 1.7. And on newsprint, which is really very poor printing paper, we can't get that high density. So a lot of this, because it's ink on paper, ink on a substrate, is dependent on the material. And you can see that here. The same ink can be printed to a higher density, 1.8, 1.5 on uncoated, 1.2, and the same for the other colors. Cyan magenta, 1.4, lower on the uncoated and lowest on the newsprint. So we see that what our understanding of printing and the measurements start to make sense, but also that throughout this 2 days seminar, we will talk and refer to the paper. And here you can see exactly why, because we're not able to put that much ink down, and the final density is much lower on newsprint, better on coated, and the best on coated. And therefore the density is higher and the color gamut is higher on better material. So even if it was the same black ink, we really need to consider the ink and the media or substrate. We will talk about delta E, and very down the bottom here in on the top, bottom left is the fact that there are different delta E equations. And the reason for that is delta E was developed to address the perceptual uniformity issues found in delta E 94. and even worse in 76. So we will talk about delta E tomorrow, but basically we should know that that's a color difference. The whole of the ISO system works on this color difference. The current one that all standards should adopt is delta E 2000. It's the best one we have. It's a very complicated formula. Luckily, the software will do that for us. But basically, we can see that if you quote the difference in delta EAB, it may be 5, while the same tolerance is 3.5. So you can see it may change from 4 to 2.8. So depending on which equation you use, the number can be 4 or nearly half of that. It can be 5 or 3.5. So you can see that just like the other metrics of the light source, the observer, we really, the measurement angle, we also need to know which equation we're using, because somebody can be saying, well, you should have printed this to 5 delta E and you're printed it to, it'd be the other way around really, but so, you know, somebody could be using 5, somebody for the same yellow could be using 3.5. For the magenta, somebody could be printing it to 4, or you could be, the customer expected 2.8. So if they're using this equation, they're expecting a match, which is closer, better match of 2.8, while you were able to print it only to 4 because you're using this equation. So if they're expecting 2.8, but they're using this equation, so that's one of the confusions. Here's a warning sign. There are 3 or 4 or even more equations. Everybody in ISO standards should use delta E 2000. Does anybody use delta E 2000 on the call? A quick chat, or do you use a different one in your environment? Can I see a quick thumbs up or thumbs down to anybody that uses delta E 2000? Was that golf cart? Was you showing me a thumbs up to delta E 2000? Okay, so I haven't seen any thumbs up for delta E 2000. Delta E 76? Maybe it differs. Maybe it differs depending on the customer. Okay, my message will be that if possible, use delta E 2000. If not, then we should specify which one we're using. And if in doubt, always specify which one we're using. If you're going to calculate it with an Excel spreadsheet, then delta E 76 is easiest to do. 2000 is a very complicated equation. Gray balance. Those of you, David Crowther talked about G7, whether you talk about, okay, oh, sorry, I didn't see the chat. Delta 2076, Delta 2000, good, Sandis, thank you. Yep, good. Gray balance is very important. And here at the bottom of the screen, I don't know if you what it looks like for you, but the middle one is more neutral for me. There's a greenish tinge and then a bluish tinge on the right-hand side. So we're very susceptible to the neutrals, but also it helps us in printing if we get the neutrals correct. And the neutrals may be affected by dot gain if there's different dot gain in the CMY channels. And so if the dot gain is different, we may not get that. Depending on the trapping and the sequence of printing, we may affect the gray balance, the density of the solids, and then any shift or in the colors of the inks, any number of mechanical conditions and settings. So there are so many things that really affect this gray balance. And this is CMY channels. We really would like them to be balanced in terms of the tone scale and the overall gray that results from the adding together the CMY and its relationship to the K. So if there was a K graph here, and we'll come back to this, but we don't want one to be very different to the others. So we create this foundation of a stable printing environment by balancing the 3 CMY. And here's a slide that we're going to look at tomorrow. But if you look at this patch here, we have this very recognizable 50-40-40. And in offset printing, in flexogravure, this 50-40-40 is the starting point that makes a gray, a neutral gray. 50 cyan, 40 magenta, 40 yellow. That neutral dot of 50-40-40 makes what is gray. So that's the starting point. But what really we need to do in all of our printing processes is continuously adjust that for the ink that you've got that day, for the monsoon weather, for the print media, and the printing process. So I'll say it again, 50-40-40 is the default starting point for traditional historical offset printing. So 50-40-40 is where we started, but all of our systems, our pre-press systems from Heidelberg, Kodak, Fujifilm, all of the pre-press systems will adjust that. And from 50-40-40, we will make it something slightly different for each printing system. And that's the gray balance that we'd like to do before we do anything else. And here's how it's measured at the 50%, at the 25%, and at the 75%. So 50-40-40 is our standard. It's cyan, magenta, and yellow ratio. To make a uniform gray, we would like it throughout the whole tonal scale, as we've seen here. But it's never going to be 50-40-40. Everybody's system, everybody's inks are going to be different. And achieving that is really a fundamental principle that gives us a stable printing system on which we can build color management and the rest of our processes that we've been talking about. We're